Series estimation theorem. What this is a way for you to kind of guess the sum of a series that does not have a finite number of terms, so an infinite series. It's a way for you to take the sum and it leaves you with an error, and the error would be your first unused term. So we're going to start this one out at n equals 1. So you've got negative 1 to the first power over 1 over 1 squared. Or times 1 over 1 squared, I'm sorry. And that leaves you with negative 1 times 1. Or just negative 1. Negative 1 squared times 1 over 2 squared. That'll be positive 1 because you're squaring that negative, and a negative times a negative is a positive, times 1 over 4, or 1/4. Let's decide quickly how far we're going to take this one. So, with this example, we're going to go to the 6th degree. To the 6th degree. So right now this is 1st degree, 2nd degree. Negative 1 cubed times 1 over 3 squared. So again, we're cubing that negative, and a negative times a negative is a positive, but times another negative is a negative. So we're going to have a negative 1 times 1 over 9, or negative 1/9. This is your 3rd degree. So we're going to start putting in sequential numbers for n. Apologies, so you've got 1 times 1 over 16, or just 1/16 for your 4th one. Everything with n at 5, so you've got a negative 1 times 1 over 25, or just negative 1/25 for your 5th degree, and finally your 6th degree. You have 1 times 1 over 36, or just 1/36, and that's your 6th degree. Now, if we wanted the sum, we would say negative 1 plus 1/4 minus 1/9 plus 1/16 minus 1/25 plus 1/36, and that would be our sum. But in this case, we don't necessarily want the sum. I'll show you all this work here. We don't want the sum, we want the error. So this would be what you would use to find your sum if you wanted that, but we want to see the error here. Our error would be the first unused term, which would be the 7th degree. So we're going to go one more time, negative 1 to the 7th times 1 over 7 squared. So you have a negative 1 times 1 over 49, or negative 1/49, and that term right there would be your error.